Are we seeing a convergence of design, construction, and fabrication softwares? We're going to take a look at it now. Sometimes it feels like we're living in a science fiction movie with technology changing so fast we can't keep up. We haven't yet reached a convergence of human and machine, but the process doesn't seem so extravagant these days. On a much smaller scale, we're seeing a convergence of software where more and more detail can be applied with great precision. This saves time, money, and change orders, both in design development and in construction and fabrication. This presentation is going to look at a major convergence for the structural steel industry, Autodesk Revit and Advance Steel working hand in hand. And by the way, that is Revit, not rivets, as you can see in this particular picture. So these are the learning objectives that we used in our AU. I'm going to, like I said, to keep it down to just an hour, I'm going to have to shorten a bit of this. But I am going to go ahead and look at the importance of level of development for structural steel design and fabrication, so you'll understand what we're talking about when you hear these terms, level of development. We're going to compare the complex steel connections in Revit and Advance Steel. There are also custom plates, bolts, and welds that are available in both products. I'm not even going to touch on those today just in terms of time. We're going to focus on connections. We're going to understand the extent to which construction and fabrication documents are created in Revit and Advanced Steel. And then we're going to look at how the fabrication workflow using those interoperability features of Revit and Advanced Steel work together. So let's take a look at our first objective, level of development, or LOD. We're going to explain the importance of this in structural steel design and fabrication. Now, way back when you were using paper drawings or even 2D AutoCAD, you didn't need to worry about LOD. Working drawings and then shop drawings were the highest level of development. But with 3D building models, you can host so much more information in the model. The question is it accurate enough for what you need to do at this point in the project? That's where level of development comes in. A little history of LOD. LOD first started as level of detail as outlined by VICO software, which is now part of Trimble buildings. It was used to specify the reliability of model elements used in automatic model-based cost estimating. So mainly cost estimating. For example, at a lower level of detail, you might specify you've got 3 drinking fountains. So there you go, your water fountains, you've got 3 of them. You really don't know anything about it. You just know that low level of detail, you've got 3 of them. Later on in the project, you're going to add them all up. You're going to have very specific water fountains. So here's our family and type, and we even know the cost. So the cost estimating now is much more accurate. So that's how the whole concept of LOD started in cost estimating from models, building models. Later, the American Institute of Architects, the AIA, renamed the concept to level of development, and that's what we're using now. And it expanded to include not just the geometric features, but all the BIM content hosted in the elements. Individual elements can be tracked according to LOD at specific points in the project. So for example, here we have a very generic connection. So we don't know anything about that connection except for there's a connection there. And then at a higher level of development, we've got a structural connection. We know now it's a clip angle with more information. BIMFORUM has expanded even on this and created a level of development specification, which is included in the National BIM standard. And so much more information. You can see this is the example here from that. And this right here is a link to that specification. The steel structures in this are covered under the shell portion with floor construction. Because it's a big thing. It covers, the whole big building. But this is actually a pretty useful tool if you want to go deeper into what's happening in level of development. Well, how much do you need to know about LOD? For now, you just need to know it exists, what the levels are, and how it impacts your workflow. it's much more powerful than what can be covered here. You can incorporate it into contracts, BIM execution plans. It can help the architects, engineers, the fabricators, facilities managers, owners start working together at an earlier point in the life cycle of a project and pass on that information with fewer mistakes. So let's take a look at it. LODs is typically specified with numbers, and the higher the number, so over here, LOD 400, the more detailed the level of development. At LOD 100, you have conceptual design, and at this level of development, structural framing is assumed to be modeled within other building elements. For example, a mass floor might include the structural framing depth, but not the specific beams or materials. The thickness and size, as well as the exact location, is very flexible at this point. When you get to LOD 200, you're into design development. The structural framing now has your approximate dimensions and sizes of framing members, but they're still fairly generic placeholders. You are expected to have your structural grids accurate, so that there's, like, say, for example, there's a steel column at this grid location, or a truss is placed between these two grid points on these columns. LOD 300 is to the level of documentation. At this level, the sizes of the main structural elements are specified on the very specifically defined structural grid with correct orientation, slope, and elevation. So much more important level here. LOD 350 is considered coordination. And so at this level of development, more member connections are specified, including typical connections for base plates, gusset plates, anchor rods, and such. You'll have some miscellaneous steel members, as well as reinforcement items such as stiffeners and sleeve penetrations. LOD 400 is your construction fabrication level, and the model's ready for detailing, fabrication, and installation. The structural model includes welds, copings, washers, nuts, and all the assembly elements that you need to actually build it. There is an additional LOD 500, that's for facilities management, and that's where the BIM model that's created with as-built information that supports the ongoing operations. Now, where are Revit and Advance Steel on this LOD continuum? The software you use will depend on the level of development you need at the time. Revit and Advance Steel are both excellent tools, but they don't do exactly the same thing. And at this time, both are needed. So earlier versions of Revit only included information up to LOD 300. So if you think about Revit, you're really getting up to your documentation level that's sent by your structural engineers. It's not ready for fabrication at this point. Then they added an add-on called Revit Steel Connections, and it moved it up into the LOD 350, a tiny bit into the 400 level for some things. A big change came about in Revit 2019, so that all the things that are in the Revit Steel Connections are also now part of Revit. So it's a basic Revit tool. All of the Revit Steel Connections are part of Revit 2019. Now, Advanced Steel is the one you want to use to get to that LOD 400, and you're going to see a little bit of that as I show you bits and pieces of it. You can go back to LOD 300. You can build a model in Advanced Steel from scratch. But as you're going to see from the rest of this program today, you're probably not going to want to. You really, if you have access to somebody using Revit who can, your structural engineers, if they can send you a Revit model, it will save you a lot of time to creating from this LOD 300 here. And so you can go right on into the 350, 400 with your Advanced Steel tools. And if the structural engineers or someone else is taking that step, you can have the Revit Steel Connections. Those all come into Advanced Steel as well. So it's a very powerful program. So let's get to the meat of this presentation, comparing how the steel connections and documentation are created in Revit and in Advanced Steel. So that we're kind of covering these two points right now in this section. The first thing to remember is that both in Revit and Advanced Steel, we're working in a 3D model. And from that 3D model, like you see here, you create the 2D documents. The model needs to be right so that the documents are right. And that means higher and higher level of development creates more complex documents. So this, by the way, is an example from Advanced Steel. So you can get very complex documents. But what you don't draw these documents. These are something that's created by the program. What you do is you model this platform, as we'll see here. Now, before we go into the demo, let's take a quick look at a comparison of the platforms. So we've got a big difference between Revit here and Advanced Steel, because you can see Revit has a white background and Advanced Steel has a black background. So, not really, but it's definitely different when I get on the computer and play around with the two. I know which one I'm in. Really, Revit, the big difference is Revit is used by architects, MEP engineers, and structural engineers. The interaction between the disciplines is seamless. So your structural grids, vertical levels, even your column locations can be copied and monitored from the architectural model without having to create them. So even as a structural engineer, you can start from information that the architect's already given you. You don't have to redraw everything from scratch. Everything's stored in one project file, including the schedules and sheets for printing. So that's a big difference between that and Advanced Steel. The Advanced Steel platform, on the other hand, is built on AutoCAD, but it is highly customized for the steel fabrication. So you can see this little palette over here. There's a ton of those palettes. And even when you look at the ribbon in Advanced Steel, totally different of what you see from your regular AutoCAD information. You can, as I mentioned, you can build a building from scratch, but you can also import and export and synchronize items from Revit. So let's go ahead and take a look at how the steel connections work. I'm going to first show you a couple things in Advanced Steel, and then I'm going to show you the same sort of things in Revit, and then I'm hopefully going to show you some of the basic documentation workflow as well, and so we can see a little bit of that in this demo. So as I said, I want to first come on in here to, there we go, Steel Platform. Here we go. So this is Advanced Steel. With what we're looking at here, the reason I wanted to show you Advanced Steel first is because the tools that are in Advanced Steel for the connections are basically copied into Revit. So we're going to see a lot of the same sort of things. Now, when I'm in here, you can see it is a full 3D model. I can, zoom in. I can do everything you can do in a full 3D model. And these items, like these columns, these beams, these braces, they are all known as elements with a lot of information. So if I could select on one of the columns, you'll notice there's an option called Advanced Properties. And this Advanced Properties, which is partially on my screen, there we go, tells us a ton of information about that column. So here you can see all there's the material, here's the section. This is, you could come in here and change the section size, your positioning. There's naming for this. So this actually, in this case, you can see it knows it's a column. Fabrication data, if this information has been done, you can add user attributes. There's just a ton of information stored in these advanced properties. So all of that information, you can select for that. The same thing is true for the beams and the individual braces. But there's another cool thing called Advanced Joint Properties. And so, for example, these braces here, let me just scroll this around. Can we see this little brace here a little bit better? So this brace is actually part of a group called a joint group. You can see there that little box around it. And if I go right-click on this, I have Advanced Joint Properties. And this is talking all about that bracing group now. So not just the individual brace, but the bracing group. And I can actually come in here and change what type it is. Say, for example, I want it to be crossed, or I want to be a double mirrored. There's tons of things that I can change in here. I can change it so that it's the inserted, whatever kind of brace. So it's actually giving me all this extra information that I'm actually changing right here for the grouping, or called the joint group. So a very powerful tool with what you can do in that. Now let's just look at a few of the same sort of things in Revit. So here's basically the same platform, but built in Revit. I have my columns, and you can see over here I have my wide flange column. I can choose from different shapes, different items. I have my little channels. I have my other beams, so wide flange. I have my braces over here, so there it is, my L angle. But you'll notice there's no link to the brace. So within Revit, I don't have that lovely little brace command that lets me create a multitude of braces that kind of joint right yet. So who knows what they'll have next year. But one thing I do have in Revit that I don't have in Advanced Steel is, whoops, there we go. You can see the little outline there. It's a structural beam system. And the beautiful part of this is I can actually set out a layout rule. You can see over here in my properties, I can have it to be a fixed distance or a fixed number. I can change the distance. So here I am just changing it to 3. You can see how it automatically updated. So within this, I actually have a lot of leeway. I'll put it back. Within this beam system. So, and creating these items like the column, I can set, to level 1 to level 2. I can easily, change it so it's going up to level 3. That sort of thing. It's very easy to create these elements in Revit. A little harder to create them in Advanced Steel. Now, the cool part of this, though, is that we aren't just stuck with these limited items anymore. We actually have the steel connections. So back to my steel platform here for a minute in my Advanced Steel, and I want to show you some of the tools that you can use. This is one of the palettes that comes with it. This is your Modify palette. There's a ton of tools in here, and I go over more of those in the other webcast from last year, which it's all the same for 2019. There's not significant enough changes. There are changes, but nothing significant. But this, I do want to go ahead and add some additional items, and I'm going to use this thing called the Connection Vault. This is another palette, and let me close my Advanced Steel tool palette. And where did my other palette go? Excuse me just a second. My Connection Vault. There it is. It was hiding. So here's my Connection Vault, and this gives me all these amazing tools for connections. And so you can just scroll on down through here, find the connections you want, and use them. I'm just going to do one really quick one here for a minute. I'm going to do a base plate, and I do want you to see that this little thing here, it tells me the selection order. Really important to know the selection order. Well, with a base plate, you've got one column, so yeah, it's not a big one. But if you're doing additional ones, you might need some more. So anyway, I'm just going to put a base plate on here. I'm going to come in here, grab my column. It's asking, do you want to select an additional concrete item? In this case, I don't have any at the moment. And so I hit no, and it popped it on in, and it brought up my advanced properties. So here you can see the little thing right behind it. We need to do something with that brace sticking out there. But anyway, I have a lot of choices here. I can set up my base plate. I can change my thickness. Let's say we needed it to be 1.5 inches. You can see, boom, it just updated the base plate right behind it. I've got lots of options. You know, my anchors, I can change those. Let's say I want them to be J anchors, you know, all of that sort of thing. Tons and tons of things that I can do with this connection. There is a way that you can make what's called joint groups, and the beautiful part of making joint groups is that they are all connected to each other. And I don't have time to show that, but it is in the other example of the other webcast. Great tool. Change one, updates all the rest of them. There's also libraries of different things, so very, very, very powerful command. Well, how does Revit match up? So here's Revit, and I've got my structure toolbar, or ribbon, and I have a command called connection. And when I come into connection, you can see that right now, all I have is a generic connection, and that's what it was for many years. But we are not stuck with generic connections anymore. When I go to my connection bar here, you can see that little button, Connection Settings. This opens up the Connections dialog box, which is going to come on up. There it is. Good. And it gives me connection groups. These are essentially the same thing you just saw in Advanced Steel. So here's my beam to end choices. Here's my column to beam. You know, here's miscellaneous or general bracings or whatever it is you need. You have all these different tools that you might need. For example, I might want to have a clip angle. So I click on it. I can either double click or I can click add. That's now loaded into this project. So you do have to load them into the projects. And I had actually set this particular one up. There's a default set, which are essentially the same default set as in Advanced Steel. You can create additional ones as well. So there are ways to do that, but of course that's like a whole other animal, how you would set that all up. And you would need to set it up in Advanced Steel, but then you can import it into Revit. So I'm going to go here. I'm also going to add I'm just going to add a couple things, the base plate and my clip angle. I now have some connections available. I go back up to my connection command, and you can see not only is my generic connection available now, but also my base plate and my clip angle. And if I hold on to them long enough, again, I get the selection order. I get an example of what this might look like. One thing that's interesting, and when you do Advanced Steel, you know, there's a lot of enters. In AutoCAD, there's a lot of enters. In Revit, you don't use the enter button that much on your keyboard, but you do have to for the Advanced Steel, so kind of watch your prompts. So let me just start with a base plate. I'm going to come down here. I'm going to, there we go, can we see the prompt? Okay, it's not giving me the prompt down there. So basically, what I do is I select it, and then I press Enter, and there is my base plate. One thing that to be aware of, if I'm at medium, all I get is that. So here's my medium display, coarse display. You know, all I'm getting is, hey, there's a base plate there. So you have to be in the fine detail level down here to see the actual base plate. So now that I've got it in here, I can easily just, you know, pop on that and then hit Enter to apply it, pop on this one, hit Enter to apply it. I want to go ahead and add, whoops, I'm selecting it still. I want to do now a clip angle. So I need to select the first thing, hold down my Control key. That's going to be, if you've been using other programs, don't forget, you got to hold down your Control key to add, press Enter, and there is my clip angle that's there. So again, to do a clip angle, select one, select the other while you're holding down the Control key, hit Enter, and you've got your clip angle. Here you can actually see a little bit of what it's all doing. So see how that comes down further? These are kind of cut back, but that one's coming over. So if I'm doing this clip angle, there, enter, it cuts it back, it places the clip angle in, select, enter, select, enter. Whoops, I must have hit delete. Whoops. Okay, here we go. Select, enter. There we go. That's what we wanted. So now, I don't want to have to go around and do every single one like this. And while Revit at the moment does not have a similar concept to that joint group where you do one and it automatically updates to the other, you can use the whole copy command and do it yourself. Now, I'm going to not do it in here because I want to do it using some datums. So I'm going to come to my level 2, and you can see here's my items right here, and I've got multiple categories selected. So I'm going to go to my filter. I'm going to check none and then just get my structural connections. So when you are trying to copy, even though there are bolts and holds and profiles there, you don't want to select those. You just want to be selecting your structural connections to copy. And I went to level 2, and that way I did not pick the base plate by mistake, because that could have been in the same thing. And right now I didn't want to copy the base plate. So I have my 3 items selected right there. You can see here's my next joint. I'm going to go to the copy command. I'm going to make sure multiple's on, and I'm going to copy it from here to here to here. So all the basic, whoops, let's make sure it's straight. The basic Revit tools work. So I can mirror, I can array. Now, when I come down here, we're going to get a warning. There you go. The shapes for medium and detail levels, they're inconsistent. We've got problems because this is a different intersection right here. So my connections are not working, and so it just didn't create the connection because we've got a different kind of a thing. But it created the other 2 pieces, so that was nice. Now you might say, oh, well, okay, I can get all of those connections. That's nice, but what if I do want to change these connections and they're not connected, and oh, that's really a pain, and how do I even change these? How do I see them? So what you do to modify connections is you select one, and either in properties, so over here, you can modify the parameters through this edit button, or up in the ribbon, there's modify parameters. Both of those do the exact same thing. And they bring up essentially the same dialog box, there it is, as the one in Advanced Steel. So you've got all of these options that you can do. So for example, I might want to come in here and change the corner shapes. I'm going to fillet all the corners here. I'm just going to change that so they fillet. Let's zoom in here. Yep, there you can see it filleted. I'm going to change those anchors and go ahead and make those the kind that are, what are the round ones? There they are. So you can see there's the round ones. But you can see that one didn't update because they're not connected at all. But no problem. I can set this one all up the way I want it to go, and then I can create a custom version of it. So I'm going to come in here to customize. I'm going to name this base plate with J-bolt. I could add additional things in here. Say if I wanted to add some welds or whatever, I could go ahead and add those things in. In this case, I just am going to make these basic changes. I click Finish, and I now have a new type. So you don't make new types of connections through the type dialog, type properties. You make them through this modify parameters because there's just so much more going on. It's, whoever created this and did all the background modification did a ton of work. So thank you, whoever created these things. They did a great job. So now the thing is I want these other base plates to match that one. Well, it's basic Revit. You just grab them. Well, you grab them and hold down your control key to get more than one. Grab as many of them as you want. And then, whoops, I've got multiple categories selected. There you go. Now I know I have just those two base plates. I just come in here, change them to base plate with J-bolt, and there they're updated. So it's, again, once you've got them in place, it's basic Revit concepts. Just use your type selector and update them. So very, very quick way to work with those. And creating the custom connections, very simple. The longest thing it is to create anything with these connections is really those big dialog boxes that show all the parts of the connections. So that's a great thing to be able to do. Very, very potent. So now let's go ahead and take a look at documentation. And while I'm still here in Revit, I'm just going to change here to my next drawing, which is Document 3D Isometric View. So that's actually a project, excuse me. This is actually a separate project, and if you have not used tabs I think they came out in 2018 or 19, I can't remember. Anyway, I love tabs. They are so nice. So I actually am naming my views a little bit more. For this sort of thing, I needed to know this is actually a separate model from that one. So I needed to know which 3D isometric view I was in, and so this is the one for my documents. This is all just a powerful lot of information. We actually, in this case, we did the base file in Revit, sent it out to Advance Steel, put in all these lovely railing items and stairs and ladders in Advance Steel, and then imported it back into Revit. So just so you'll know, that's how we got that complex of an object. So let me get to my steel platforms. And here I've got also one that's more, it's ready for documentation. So there are some things that you can do in Advanced Steel, needless to say, that you can't do in Revit. And one of those is these railings and all these pieces of railings. These stairs, I would never attempt those in Revit. And they're very easy to put in Advanced Steel. Well, just like we have some special tools for the Advanced Steel, we have the Connection Vault. We also have special documentation tools. And so if you can see that over here, my screen's not quite wide enough to show you those out at the moment. Next week, I will have a new monitor that'll be a widescreen monitor. I'm looking forward to that. So anyway, the way you start working in documentation, and I have to do this to do the documentation, is you number first all the items. And it numbers all your single parts and all your assemblies. So I'm just going to, in this case, just use the defaults that are in this dialog box. But again, extremely powerful tool, numbers everything. Yes, I want to start the command and do that. So you can see down here at the bottom, whoops, there it went. And there it has numbered all the objects in here. So each one of my, there's 4 of these at C part numbers. All the different parts are listed. Then I can go and create drawing styles, drawing processes, bill of materials, templates. I've got all these things I can now build from this. And I'm just going to bring up drawing styles and drawing processes here. There's drawing processes. Here's drawing styles. Okay. So again, these things are trying to dock them so they'll be available for me to use in a second. Different things that you can do, and again, I show more of this in the Advanced Steel tools. I'm just going to real quickly do an anchor plan here for you. I'm going to click Anchor Plan, I'm going to create it with the default settings, which is using a certain prototype of title block. Then I'm going to select, I always forget how to select things. Whoops. Sorry about that. I always forget how to select things in here. Let me zoom out. And yeah, there we go. All right, we're going to create with the default settings. Did I do it? Well, we're going to try again. All right, so now what I'm going to do is go into something called the Document Manager and see if I did it correctly. Sorry about that. I've got my details. This is I've actually got, I did get 2 drawings. So these are what's created when you run these drawing processes and things like that. And I can get a preview. You can see there that was the drawing 1. I didn't select the right amount of things. Let's go to drawing 2. I did. Oh, here we go, anchor plan. And I didn't get that right either because it's actually picking additional stuff. I'm sorry, I didn't get a very good anchor plan there for you. But you can see that it's actually creating the information that I need. I think I needed to go to Plan View. And I'm sorry, I'm forgetting what this is. I don't use the Advanced Steel as much as I do use Revit. But anyway, it will give you the exact information you need in an anchor plan or whatever it is you're working on. And you can also get drawing processes, let's see, like all the single parts. I'm going to just pick a small little section here. See if I can't get this. So this is, it's doing more than I was thinking. All right, we are waiting. I should have selected single parts. Here's a way you could have selected an area. And so it's now actually getting all the single parts. Oh my goodness. I'm going to have to stop that. I picked the wrong thing there for us. Let me just see if it did put anything in here. Okay, no it didn't. Let me go into the other thing. Here's the selected single parts. So sorry about that. I picked a big one. We're going to select single parts. And now I'm going to create a little lasso around something. It's the downside when you use Revit instead of AutoCAD on a regular basis. Let's see real quick if we get this. If we don't get this, I'm going to have to go back and show you what's in Revit too. We've run out of time. Document Manager. There we go. I think we got. Yes, there we go. So here's some of my part sheets. You can see there it's actually taken each one of those parts and giving me all that information. And I can actually open these drawings. And all that was created by my kind of fumbling attempt at selecting objects. But that is very, very powerful, what this can do, all of these things. You'll also notice that in here, like we can do, like I said, the bill of materials. You can also do NC files, so putting it out to the NC module. You can do DXF, and some fabricating equipment uses the DXF. So you can do those things as well. And then this is the NC setting. So if you are using NC, you can set it all up so that it can go straight to fabrication. Very, very, very powerful tools. Well, how about Revit? Documentation for fabrication. So I can come here and I can make an anchor plan. This is an example of an anchor plan. I had to go in and do everything. I had to delete stuff I didn't want. I had to add these dimensions. I had to add the tags. As you can see, not everything's tagged. And in some cases, like the holes. I wanted to do the holes. Revit dimensions don't acknowledge those holes existed, so I had to draw detail lines. That's what those little things in there are. I added detail lines so I could actually dimension my holes. So very limited fabrication documentation tools, nothing to go to the full fabrication things. You can't send it directly to the fabrication equipment of any kind. Excuse me a second. So, back to our PowerPoint. As you saw the comparisons between Autodesk Revit and Advanced Steel, you can see that the level of development impacts which type of software you need to use. So what we want to be able to do is develop this complete design to fabrication workflow using the interoperability features. You could see that there's great things that happen in Revit. There's great things that happen in Advanced Steel. We're not ready for just one program yet. So how do we get the two to talk to each other? Because as you know, Revit and AutoCAD aren't necessarily happy to talk to each other all the time. Every year, better and better, but you still have to do a bit of work. So what I have here is Revit with design. You can build on the architectural model without having to recreate datums, your column locations, from scratch. It's a big asset to using Revit for the design development phase of a project, and even into the basic documentation. So before fabrication, I would use Revit for all those things. So don't try to do documentation before fabrication in Advanced Steel. Really use Revit. The basic documentation in Revit's a good thing. It's so much smoother than creating them in Advanced Steel. And the fact that you can now add those detailed connections to Revit allows even more control over design by the structural engineers if they are doing it at that level. And so it could be that if you are working on almost a design build project, you might want to stay in Revit a little bit longer now and do some of those connections, because if there's a change, then you don't want to have to do all the translation back and forth. You want as much happening in Revit as you can. So it really depends on how your office wants to work in this particular case. But when we do get to fabrication, you do want Advanced Steel. It has tools that make the model so much easier to develop to the full LOD 400 that's needed for the construction fabrication time. For example, as I mentioned before, creating steel railings and stairs to this full level of detail should not even be attempted in Revit. The documentation tools are very helpful, designed specifically for fabrication, where the Revit documentation tools are useful but generic. So even though you may be using only one or the other of the two programs, it can help to know how to share all your lovely data with other people of the design to fabrication team. And so I just want to show you kind of a quick demo of what you would do in exporting, importing the products. So I'm going to go back to Autodesk Revit, and I'm going to bring up here my export to SMLX. So this is a big file, a nice big file. I want to export this to SMLX. This is an add-in. So you can see I've come up here to my add-ins tab, and here it is, my Advanced Steel extension, a free extension you can add in. And I just go and I'm going to export it. You have a choice to do an advanced export. That's the one that's going to go to Advanced Steel. And then you can also choose other formats. And I could click OK here, but then it would start going clonk, 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 clonk in the background. It's pretty quick, but not quick enough for a webcast. So I'm going to cancel that for the moment. I'm going to go to my flat steel platform. Let's see, I'm going to do a new drawing. I'm using the Advanced Steel template. Always, always use one of their templates or one that was created from one of those templates. Click Open. I have Export Import here. You can see I have a tab, Export Import. I'm going to import an XMLS file. So let me get in here. I'm going to use that one, the one with no floors. So I had one I had already made. So now that this one's coming on in, we're going to wait a second while it does its translation. There you can see the import status happening down here in the lower right-hand corner. So very quick. I mean, that's a big building that I just exported. And we're import status moving on up. Oops, there it is. Oops, let me wait just a second. So here it is. We have our full building here. I'm going to change up here in the upper left-hand corner here. I'm going to change from 2D wireframe to conceptual. Just zoom in here a little bit so you can see there it is. There's our lovely beams, columns. These little green things are shortening, and I'm not sure. I'd have to talk to somebody who uses this a little bit more, but if you want to add in the things like a clip angle here, you want to get rid of those shortening things first because you want the tools to do it. So for example here, connection vault, I want to do, where was it? There's a clip angle, and I'm going to select this. There we go. And so there's my clip angle in here, and of course I can go in there and you know, get it to the right size, but it does the coping and everything for you. If I had left that little green thing in there, it would have not cut it back right. So I'm not sure how you would deal with that particular thing. So that's a question I might, you know, find out what that would be. So as I showed you in Revit, when I looked at this document here, you can also import it back in, and then you have all of these tools. Like I said, you never would draw that in Revit, but there's your railing and everything, and it's available in Revit, and I could, you know, modify some things as well. So you can then bring it back and forth. There is synchronization that you can do as well. So you can see now that Revit and Advance Steel seem to be converging, but there's still a place for both softwares. So we covered that whole concept of level of development for the structural steel design and fabrication. We compared, in this case, just the steel connections, the complex steel connections in Revit and Advanced Steel. You got to see a little bit of both of those. We did a little bit of the construction fabrication documents where Advanced Steel starts winning. And then we talked about the fact that you can go ahead and export and import and even synchronize Revit and Advanced Steel tools. So very powerful information. Now, if you'd like to see our Autodesk talk and see especially the documentation work much better, you can go to autodesk.com and search for BLD 225500. That is BLD 225500, and you will find our talk there. You can download the class files. You can download the but there's a PDF of the document too. There's you know, it gives you more information there, and then of course you can watch the video of the full thing as well.